Hello everyone, my name is Bianca and I'm a developer advocate here at Prefect. I'm really excited to walk you through the many options that Prefect has for scheduling, deploying, and making your workflows resilient. Let's get to it.
In this session, we're going to use Prefect to add a touch of resiliency to an MLB pipeline that runs some statistical analysis on box score data. We'll be exploring the various options Prefect has for retrying workflow failures without having to write a bunch of defensive boilerplate code. We'll also see an example of how Prefect's transactional interface allows us to implement things like rollback hooks to clean up any extra cruft that may be left behind when a failure occurs in our pipeline. Last but not least, we'll schedule the pipeline and deploy it using Prefect's managed infrastructure. That way, we can safely walk away from our laptops and the workflow will continue to run. If you're planning on following along at home, I'd recommend completing the prerequisites in the README at the root of the DevDay repo, and the README that is in the Track 1 folder. You'll need a free MotherDuck account, an AWS account, an S3 bucket, and a few Prefect blocks to run these examples yourself. The README in the Track 1 folder has all the details for setting those things up, so follow those instructions and you should be good to go. Without further ado, let's get started. If we navigate over to this Resilient Workflows folder, we'll find our MLB flow. This pipeline fetches and analyzes MLB game data for a specified team and date range. It retrieves game schedules, fetches game box scores, performs data cleaning and analysis, passes the raw data into an S3 bucket, and stores the processed data in MotherDuck. Lastly, it creates a markdown report as an artifact, which contains a summary of the game box score statistics loaded into MotherDuck, along with a table displaying the raw data that was stored in S3. Let's run this workflow and take a look at the flow run in the UI. As you can see, we've got a lovely little diagram. If we scroll a bit, we can find our artifact that contains our summary report. That was fairly painless, but the reality is life isn't always this easy. Workflows fail no matter how good our intentions are. With Prefect, however, we don't have to surrender to failure. There are things we can do to mitigate worst-case scenarios and keep our workflows up and running. With that, let's explore the different options of retries that Prefect has to offer. For the following examples in the retries folder, we'll simulate occasional failures when calling the MLB API. Prefect can handle these failures gracefully in a streamlined, built-in way that minimizes the need for writing extra defensive code. The first retry option is quite simple to implement, and we pass it right into the task decorator. The task itself also has a few lines of added code to simulate an API failure. If we run this, we'll be able to see some logs showing that the task is retrying and how many retries have been exhausted. If we manage to not encounter an exception, the workflow will proceed as normal. For the next retry option, we'll take a look at adding a retry delay to the task decorator as well. The retry delay seconds parameter is used in Prefect to control the delay between retry attempts for tasks that fail and need to be retried. There's a few things to note about retry delay seconds. One, that it captures a list of integers allowing for customized retry behavior. Two, each integer in the list represents the number of seconds to wait before the next retry attempt. When we run this flow, we'll be able to see that the start of each consecutive retry takes 1 second longer to complete than the previous one. Aside from passing in a list of integers, there is another option for adding a delay between each retry, and that is with exponential backoff. Exponential backoff is a utility function provided by Prefect to automatically generate a list of retry delays that correspond to an exponential backoff retry strategy. Some key points about exponential backoff to note are that 1. It's used in conjunction with the retry delay seconds parameter in task decorators, and 2. It generates a sequence of increasing delay times between retry attempts. In the example we have here, the task is set to retry 4 times with a delay of 2, 4, 8, and 16 seconds. If you're wondering why it's necessary to even have delays between task retries, it's so that we can avoid accidentally overloading an API by making too many consecutive requests at once. Doing so opens the doors for rate limiting and other unpleasant consequences. For the last stop of our tour of retries, we have the custom retry. We're able to configure a custom retry by creating a handler and using the retry condition function argument. Some things to note about this argument are that 1, it accepts a callable or function that returns a Boolean value. The function or handler takes 3 arguments: the task run, and the state of the task run. 3, if the function returns true, the task will be retried. If it returns false, the task will not be retried. All in all, custom retries allow for fine-grained control over when a task should be retried based on specific conditions. For our handler, we're not going to bother retrying if any exception aside from this timeout error is thrown. Alright, that sums up the retry examples for this session. One thing that we haven't considered yet is that failures often leave behind side effects like partially completed database updates or incorrect files. Prefect's transactional interface helps manage and undo these side effects seamlessly. Let's navigate to the Rollbacks folder to get to our next example. Now, for those of you that are hearing about Prefect's transactional interface for the first time, allow me to elaborate a bit more. Prefect's transactional interface enhances task execution and pipeline idempotency by introducing transaction-like behavior to workflows. Under the hood, every Prefect task run is governed by a transaction. We can use transaction blocks to group tasks as an atomic unit, allowing for precise control over retries and execution. Transactions also allow us to leverage on-commit and on-rollback hooks to handle side effects and failures. In the case of an on-rollback hook, which we'll be exploring in this next example, if a task in a transaction fails, all associated tasks are rolled back, preventing result persistence and enabling resilient idempotent pipelines. Let's check out our on-rollback hook. This deletes the raw file if there are insufficient baseball game entries. If there are too few games, we can flag that with our quality test function. Since we're interested in running a statistical analysis on game data, we need a good sample size in order to draw any meaningful conclusions. If our initial query to the API isn't returning sufficient data, there's no need to continue the execution of the flow and waste compute, or keep the raw data files and waste storage. In our flow function, we've defined a transaction block. Within the block, you can see that we're calling the function which saves the raw box score data to a file, the quality test function, and last but not least, the function that loads the raw data to S3 for storage. We've also defined a key value pair containing the raw data file name for the transaction so that it can be accessible to our onRollback hook. That'll ensure it deletes the correct file if the data quality test is failed. Just to show this onRollback hook in action, we can call this flow using a date range that will yield less game data than is required by the quality check. With the 10-second buffer that happens before the rollback is executed, we can see the raw data file spawn in and out of the raw data folder as it gets deleted by the rollback hook. As we close the chapter on rollbacks and transactions, let's gear up to deploy this flow to serverless architecture and explore what kind of schedules we can use. Prefect offers a variety of scheduling options to accommodate different workflow requirements. Schedules are applied to flow deployments. A deployment in Prefect is a packaged, reusable configuration of a flow defining how, where, and when it should be executed. When it comes to assigning a schedule to a deployment, this can be done in three primary ways: through the Prefect UI and through the CLI or Python code. Here you can see that I've commented out a few options for scheduling. One of the most commonly used types of schedules are cron schedules, which use cron expressions to define precise runtimes. This allows workflows to be scheduled for specific times, days, or months, such as running every day at 1 a.m. Another straightforward option is interval schedules, which executes workflows at regular intervals, such as every hour or every 10 minutes. And last but not least, for more complex recurrence patterns, Prefect offers support for R-rule schedules. This allows for intricate schedules like running workflows on every Monday, Wednesday, and Friday of the month. Beyond just discussing scheduling options, let's talk a bit about what this script is doing. Here you can see we're using the .deploy method to deploy our flow. The .deploy method is used to define a deployment using Python and can be used to submit work to dynamic serverless infrastructure, which we're leveraging for this example. We're going to deploy our work to a managed execution work pool, which you can see is defined here in the code. A managed work pool is a type of work pool offered by Prefect Cloud that allows you to run flows on Prefect's infrastructure without the need to host a worker or configure your own cloud provider infrastructure to run your work remotely. Let's go ahead and create a managed work pool in the UI and give it a name that matches the work pool we've set in our .deploy function. One last thing I'd like to point out in the code is that we're making use of the fromSource method as well. The fromSource method is used in Prefect to specify the location of flow code when creating deployments. It's particularly useful when you want to pull flow code from a remote location at runtime rather than having it baked into a Docker image. You can see that it takes two arguments, a URL to a Git repository or storage object, and the path to the file containing the flow and the function name separated by a colon. Let's go ahead and run this to create our deployment. Now that the deployment record is here, I can show you how to add a schedule in the UI if you'd prefer to do that over defining it in code. We can see scheduled runs begin to pop up according to the schedule that we've defined. Let's go ahead and kick off a flow run of our deployment manually and see what happens. Cool. We've taken a flow that has only been running on our local machine so far and run it using serverless architecture in Prefect's managed execution workpool. In this session, we've covered quite a few key Prefect features, from handling failures with retries and rollbacks to automating workflows with schedules. Prefect ensures your workflows are not only automated, but also resilient. Thanks for tuning in. If you have any questions or want to explore more, feel free to reach out in the Prefect community. Take care.